Week 8, lesson 1. So this video is on relations, functions, domain, and range. It's a lot of slides and you are welcome to download it. I wouldn't expect you to print them though, because again, it'll be a lot of paper if you print them all out. Anyway, moving on. So let's start by talking about the definitions of all these things. And again, you can read this and this is definitely not the first time that you have done functions. So a relation is just a set of ordered pairs, okay? And you can show that a lot of different ways, okay? There's a set, there's a mapping, a graph, or an equation. The domain is just the x values. The range is the y values. And then a function is just a special relation, okay? And it's special because every element of the domain is paired with only one element of the range, okay? You may have to keep referring back to this, all right? And then there's also this part, and this part kind of gets overlooked. The function must act on every element of the domain, meaning you can't have some x value that is not paired up with any y value at all. Okay, so scooting this up. So the question here is this a function? The answer to this question is yes. And you may remember something called the vertical line test, right? This works great on graphs, where if you can draw any vertical line, all right? And again, I could do this all day long, but any vertical line that you choose to draw can only touch the red graph once, right? Because that means that every x value is only paired with one y value. Okay, this is what a mapping looks like. All right, so these would be considered over here the x values, and these would consider the y values. Okay, now keep in mind the definition of a function is that each element of the domain, that means the x's, can only be paired with one of the y values. So because here Belgium is paired with both I don't even know how to say these two things, brands of chocolates, but whatever the case, it's paired with two different things the same way that Switzerland is paired with two. This one is not a function. Okay, trying another one. This is just set notation. Okay, set notation. The domain is going to be these x's, right? And the range is going to be these y's. Okay, so for this to be a function, each element of the domain can only be paired with one element of the range. Well, the fact that you are seeing 3 paired with a couple different y values means that it's not a function. Or you can use the 4s if you want. The 4s are also paired with different things, so this is not a function. All right, again, let's try another one. Okay. Anytime you see a graph, I highly recommend the vertical line test. So if you draw any vertical line, it only touches the red graph once, right? So this is a function. Okay, this looks really similar to the last mapping that you looked at. All right, in fact, it's the same countries, it's the same brands of chocolate. They've just switched it around so that these are the x's and these are the y's. And in this case, it's a function. Okay, in this case, it's a function. Again, look at every single thing over here in the x. It's paired with one thing, paired with one thing, paired with one thing, paired with one thing. Right? It doesn't matter that Belgium is paired with 2. It matters over here. You have to look at the x's. Okay, let's keep going. Okay, so again, another set notation problem. Again, you're looking at the x's. You're trying to see if these x's are paired with more than one thing, but those are all unique. This is a function. Okay, this one. All right, again, I'm a big fan of the vertical line test. Let me just draw in a vertical line for you. Maybe this one, okay? It only takes 1, but if you take a look real close, you can see that it touches 1, 2, 3 times. This is not a function. Okay, this is a sideways parabola. Again, all it takes is one line to prove that this is not a function. Ooh, okay. Okay, so this is something new. You, I guarantee, have seen notation that looks like this, okay? This represents the numbers that are between -2 and 6. -2 is included, 6 is included, and it's all the numbers that are in between, right? There's some negative numbers in there, there's some positive numbers in there, there's fractions, there's decimals, okay? Again, you're used to this notation, but from now on, you are going to be required to use what's called interval notation, which is what you're seeing over here to the right of the squiggly line. Okay, now you'll notice on this one that the brackets are sort of hugging. I don't have a better word for this, okay? They're hugging the 2 because 2 is included, right? There's an equal sign here. Likewise, over here on the 6, they are hugging the 6 because the 6 is included. Okay, now take a look at this next one. I'm going to switch colors. Okay, so I'm looking at this one in green. If I had you graph that on a number line, right, you'd have -1 over here, and you'd have +5 here, and these would be open circles because the 1 and the 5 are not included. Okay, that's what these symbols over here mean, all right? If the brackets are facing the other way, it means that you can get really close to this -1, but it's not included, okay? And the 5 is also not included. This represents all the numbers between the -1 and the 5, in between them, but not including the end points. Okay, and then if I switch colors here, that was a big mistake. Let's try, I forgot to pick highlighter. Here we go, highlighter, there we go. If I graphed this, you know that this would be a closed circle on 4, and it's all the numbers that are greater than it, right? Forever, sorry, sound lot. Anyway, so as far as the interval notation, you can see here that the bracket is sort of hugging the 4, right? It's included sort of around the 4 because the 4 is included, but you'll never ever be able to get to infinity. Okay, infinity is not a number, it's a concept. So this symbol cannot ever point towards it. By the way, you may say some of these answers that have a negative infinity, right? That's if your shading on the number line goes in this direction, right? So positive infinity and negative infinity are going to be things that you see. Okay, so let's move this up. So now looking at this problem, we're looking at the domain and the range. Okay, the domain is dealing with the x values, and you can see that the x values go from here, right? From here in that direction. Okay, so in interval notation, the -4 is included, and then it keeps going forever towards infinity. Now, the range is the y values. Okay, and as this keeps going, it goes up and up and up and up and up forever, and this will keep going down and down and down and down and down forever. There is no top, there is no bottom. Okay, it goes from negative infinity to positive infinity. And notice that my symbols, right, they do not hug those infinity symbols because you'll never actually get there. Okay, let's take a look at this one. So again, determine the domain and the range. Domain is talking about the x's. Okay, this is going forever this way. This one's going forever this way. And because of these closed circles, right, because of the closed circles, every single x value you could ever envision exists on this graph. Okay, it goes from negative infinity all the way to positive infinity. Okay, now let's take, I'm going to switch, I think it's going to, yep, it deleted it. Sorry about that. Let's switch colors and do the range. Okay, so the range is looking at the y values, and you can kind of see that this graph bottoms out right here, right? The graph bottoms out. The lowest value that I can find is 0. It is inclusive. And then it goes up forever from there. So it goes to positive infinity, non-inclusive. Okay, again, let's keep going. I have got a lot of these, okay? I want you to just, see them, get a bit more practice on them. Here we go. So the domain and the range. Here we go. Domain is from left to right. This goes forever to the left. This goes forever to the right. So it's going to be from negative infinity to positive infinity. And if I switch colors, the range, right, this goes up forever. This goes down forever. It's also the same. It's negative infinity to positive infinity. Ooh, this one's a fun one. I really like this one. Okay, so let's take a look first at, again, domain, the x values. Okay, so no matter where I go on the x number line, right, it seems like I can find part of this graph, right? There's something there, something there, something there. No matter where I go, there is an x value. So this goes from negative infinity to positive infinity for the domain. Okay, now the range, let me get rid of some of this stuff. Okay, the range, which I'm going to do in a different color, this is just the y values. Okay, so you kind of have to really think about this. The range, I see like there's a -4, and there's a -3, and there's a -2, but there's none of the fractions, right? There's none of the fractions at all. The range is just integers, okay? Which is what I'm going to put is the symbol z, which represents integers. Okay, there's no fractions, there's no decimals, but integers are all the range values. Okay, let's scooting this up. Ooh, this one's interesting. This is just dots. Okay, so sometimes you may have to put your domain and your range in set notation. So I'm going to do the domain in pink, which is just the x values. So I can see there's a 2, a 3, a 4, and a 5. 2, 3, 4, and 5. Those do need to be written from low to high. The range I'm going to do in blue, and I can see that there's a 1, a 2, a 3, and a 4. 1, 2, 3, 4. Again, low to high. Okay, scooting this up. Ooh, okay, this is interesting. Okay, so as far as domain is the x values. It looks like I have x values everywhere except where there is an asymptote. Okay, so you're going to go ahead and do this in interval notation. This continues on to the left forever, so from negative infinity until I get to this asymptote at -2, which is not inclusive. And then it's going to be that with the union of, right, and you've seen this notation before, back in week 4, and then it picks back up at -2 all the way to positive infinity. Okay, so this is the graph that's to the left of the asymptote. This is the graph that's to the right of the asymptote. Okay, now if I switch colors and we do the range, you can kind of see it does something similar. Okay, let me get rid of some of this stuff. Sorry, it's going to get rid of the whole answer. All right, so if I do the range in pink, and again, this time I'm looking at the y values, I can go from, right, this keeps going down forever. So I'm starting down here at negative infinity, and I'm coming up to an asymptote that isn't drawn, right? But you can kind of see that it exists right here, all at 0. And then that's the union of, and then it picks back up, right? We're close to 0, but it keeps going on forever to positive infinity. All right, so again, this is the graph below the asymptote. This is the graph above the asymptote. Okay, oh, sorry, a little too high. There we go. Okay, so if I'm going to do, I'll do domain in pink. Domain is the x values, so I'm going, you can kind of see it goes here from -3 to 2. But notice these are open circles, right? They are open, which means they're not included. So from -3, non-inclusive, to 2, non-inclusive for the domain. Now the range in blue seems to come up here to 2, and it bottoms out here at -5. So -5 is not included because of, again, of that open circle, but the 2 is included. All right, again, because you can actually see there's there's no open circle up there at the top. The 2 is included. All right, and then I think we may, oh, interesting. I don't know how to, well, maybe I'll have to get rid of them this way. There we whoa. Interesting. I have no idea what, okay, that's not good. There we go. Let's try this. Okay, I think this is my last one. It is, okay. So the domain and the range on this one. Let's see, it looks like I'm going over here from -3 all the way to 1. Those are both inclusive. And the range, it looks like I am topping out here at 0, and my lowest point is down here at -4. Oh, that's a 0. Sorry, that is a 0. And those are both inclusive.